The next fan in the HST line is the DS82. That fan is based on the core of the DS98, so again we have a 60mm motor here, but now we have a reduced diameter of 120mm. We had the idea of taking the really famous DS98 and reducing it in size. We brought it to 120mm diameter, which is a classical size for EDF aero modeling. That's the size for the models of around 10 to 11 kilograms. It has the same features and the same motor choice as the DS98, or as a bigger brother, so to say. We have the 60mm motor in the aluminum stator. We have again the four-bladed stator design. And we were able to keep the high efficiency level despite the lower diameter. Let me walk you through the motor choice for this fan. For the smallest motor which is available, we decided to go from 12S to 13S. That's possible because the torque of this smaller diameter fan is a little bit lower. So let's start with the biggest motor first. If we go for the 6043 with 650 kV, we will have a total weight of the system of 1,320 grams, and we will get a thrust of 115 newtons. The current draw is reasonable at 165 amps, and the total efficiency of the system is 72%. The RPM level is quite low, that's only 30,000 RPM, so quite a high torque on the other hand. And the exhaust velocity is high. We can expect 109 meters per second here at the rear end. Then the second biggest choice is the 6036 motor with 600 kV. The fan gets lighter with that one. It weighs 1,240 grams then. And the thrust, of course, is a little bit reduced due to a lower current draw, so we can expect 91 newtons here. And then, last but not least, the lightest motor, the 6029, will reduce the weight of the system down to 1,070 grams, and we can expect a thrust of 78 newtons on 13S LiPos. Let me walk you through the fields of use for this fan. So as I said before, it's the smaller brother of the DS98 HST. This one is called the DS82, so it has a smaller fan-swept area. At the same time, this means it can handle smaller intake areas and outlet areas. So it's made for big jet models at a weight of maximum 12 kilograms. But if these models cannot offer the inlet and exhaust size, this fan is always a very good choice. It's a nice replacement for a typical 10 kilogram kerosene turbine. It's very clean, it's quiet, but it delivers a great jet sound. You can just hear the swash of the air. There's no mechanical disturbances or anything like that. It is also a good choice for UAV applications, for the faster ones. You can go up to 550 kph with this fan. That requires a very unique installation where we are pleased to help, of course. And because of its high power capabilities and the extremely good cooling, it's a great choice for VTOL applications. So during the hovering phase, the fan can give a very high power for a limited time, of course, like 30 to 45 seconds, but it will not overheat during that time. If we go then horizontally at a reduced power, the fan can thermally relax a little bit, so we have a very nice system for such an application. It's nice for distributed propulsion projects. It's often the choice for R&D projects. Due to the smaller diameter, it fits into wind tunnel models. And it can act as a very high power cooling fan, as a blower for firefighting applications, for example, or it is used as a thruster for stabilizing loads.